Welcome to the digital signal processing class. Now today we'll discuss about the we were design we were started with design of digital FIR filter, and we have finished one of the most important topic, that is calculation or design of FIR filter using window method. And now today we will discuss the second method, that is design of FIR filter using frequency sampling method. Now, one of the most important point that what you should understand in this topic is, when we try to design a digital FIR filter, one point is already clear to you, that is we need finite impulse responses. Right? Okay. Now, what is impulse responses? You already familiar with impulse responses are nothing but h of n. So ultimately your goal is to find out h of n. Once you get the h of n, there are n number of ways to go or to obtain h of z. The problem is, what will be the question, how from which part we are coming with. See, in both the design, in either in window method or in frequency sampling method, so your input will be desired h of e power j omega. What is this? So this is nothing but Fourier transform. I have a equation which belongs to Fourier transform. From Fourier transform, I am trying to obtain h of n. That's it. The point, you should have a clear picture that what we are trying to do here in this case. So in previous class, there was h of e power j omega. We solved this equation, right? H h of e power j omega equal to e to the power of minus j 2 times omega, right? So how it looks like theoretically, I mean, pictorially, if I draw this, so this is something else. This is how it looks like, right? E to the power of, and it is decreasing. So it is decreasing. So omega is decreasing as you keep on putting the values of omega. The h of e power j omega is decreasing. Now, obviously, if you look this, it is nothing but a symmetric in nature, right? Symmetric nature. Hence, if you remember the previous problem, h of n was also symmetric values, right? Now, one of the method what we did was, see, we take this Fourier, anyways this is in Fourier transform. What we did in the previous class, we took inverse Fourier transform. So that was the way we could obtain hd of n. Okay, from this we obtained hd of n, and this was infinite in nature. Infinite in nature. So again, we multiplied this equation or these infinite value with a window function to obtain finite impulse responses. So because window function will give me the value stating that, say for example, if the window function, or if I'm choosing the having window, I'm having this equation cos 2 pi n by m minus 1. So what is this m? I should choose how many samples that is required for me. So when I say that these many samples is, for each and every samples, omega is multiplied with hd of n, and those many samples of h of n is going to be obtained. That's it. If I say 6 here, so therefore that is 0 to 5 values are obtained with w of 0, w of 1, w of 2, and so on, w of 5, and each of these w values are in turn multiplied with hd of 0, hd of 1, hd of 2, and so on up till 5. So that is 6 values of window function are multiplied with 6 values of infinite hd of n, so that in turn the output will be 6 values of h of n. So finally we could able to fetch finite values of the impulse responses. Okay, this is one technique that what we have observed in our previous session. Now let me have another technique here. So as I already told you, this is again I'll take a same example here. Same example here. So this is once again a frequency uh, values. Fourier means it is nothing. Fourier transform is nothing but which is already in terms of frequency domain. Now this is in continuous time CT signal. So what I can do is in a second way, if I want to obtain the samples of this, what is the required? So ultimately if I go for taking the samples, that itself is one way of obtaining the h of n, right? So I take a samples of this, I take a sample here, I take a sample here, I take a one more sample, I take a one more sample, I take a one more sample, I take a one more sample here, I'll choose a one more sample here. What is this technique is called as? What is this technique is called as? Anyone? Oh, this is what quantizing other way. What we where we applied this technique in our DSP. So it is nothing but, so I had a DTFT, and DTFT to DFT we did the same thing, right? I had a DTFT equation which was a continuum of frequencies. Okay, I obtained the samples for k n number of samples or n point. So then I called it as a n point DFT, right? Is it not? So here also I have a Fourier transform. Okay, here also I have a Fourier transform which is nothing but a quantum of frequencies. Now therefore I can obtain h of e power j omega. I will sample this omega with respect to 2 pi by k number of sample 2 pi by k number of samples with m point. That's it. I sample this omega frequency. This is going to be sampled. So for entire range of 2 pi, and this is a k equal to 0, k equal to 1 sample, k equal to of such how many samples I will take of such. So it might be m point. So now it is as good as I can call this as h of k. What is this? It is nothing but a DFT equation or not. What we did, the which is already in a frequency domain, Fourier transform h of e power j omega. I go for sampling this technique. So I got a sampled version of h of e power j omega. I got a sampled version of h of e power j omega. I am trying to sample that omega with respect to 2 pi by m into k number of samples. So hence we call that technique as frequency sampling technique. So once we obtain this, what is this DFT? So what is required for me? What is required for me at the end? I required h of n, right? How do I come from h of k to h of n? What should I do? What should I do? What should I do to obtain h of n from h of k? What we do to obtain x of n from x of k? What was the procedure that we did? Guys, are you there? Are you there? What procedure that we followed when DFT is given? If I want to have x of n, what was the procedure that we followed? Inverse DFT, IDFT, very simple, right? So similarly, if I need impulse responses, which is where h of k is nothing but a sampled version of my h of e power j omega, then if I want to obtain h of n, what I should perform here? It is nothing but IDFT, is it not? So very simple and straightforward approach. As the same thing we apply here, the technique of DFT we try to apply here to obtain the h of n sequences. That's it. So here consider FIR filter whose desired frequency is HD of omega. where this frequency hd of omega is uniformly sampled at m points as such a frequency sample that is given by omega k equal to 2 pi k by m. So where k runs from 0 to m minus 1. The sampled frequency, what is that sampled frequency? It is nothing but a DFT and it is denoted by h of k. Obtain IDFT of h of k so that we get a impulse response of h of n, right? The problem is I need to satisfy some condition here, the only condition for FIR filter to be realized. So ultimately I have a h of n from this previous value from this technique. So I had h of e power j omega. I sampled this at 2 pi k by m sampling technique I perform. I obtain h of k here. So this is nothing but a DFT. Now I obtain IDFT. I perform IDFT. I will obtain h of n. Now from this, what is required? I required FIR filter. So to obtain FIR filter, so it is nothing but h of z I need. So where h of z should consisting of only zeros but not poles. That's what the basic fundamental definition of FIR filter. FIR filter consists of only zeros. It does not consist of poles, which means that h of z in FIR filter it consists of only numerator terminologies. There is no denominator. Now to obtain h of z, from this the coefficients of h of n should be the real. Then only I can able to perform. For this to happen, which means to make sure that h of n is real, we have to follow the conditions. The two conditions it has to be satisfied. One is h of 0. The first sequence must be a real sequence. And h of k must be a complex conjugate. So that is, we already know that what you mean by complex conjugate from my DFT definition. So these two conditions must be satisfied. If these two conditions of h of n is satisfied, then I can go for, I can easily design a FIR filter from frequency sampling technique. Okay, so directly we try to solve this equation again, which is almost same kind of problem that I am considering here. So last time it was e to the power of j minus 2 omega, and here in this equation it is e to the power of j 2 minus 3 omega. I will try to solve this equation. So before to that, okay, before to that, there is a small derivation part, like we have to understand, right? One is, that's what I told you, that h of k was present, and h of k was obtained. So from by, so this was the given equation, let us assume. So what we did, we have obtained the sample of this h of e power j omega in terms of, so Fourier transform. Let me take minus. Now if I want to sample this, so this I am going to sample at this point. So I am going to get h of k. To get h of n, I simply take that IDFT. So IDFT definition is 1 by m summation k runs from 0 to m minus 1 h of k into e to the power of j 2 pi k n by n. So where this is the condition. So once I have this condition, so the as I told you, h of n must be real or h of 0 must be real. So to obtain h of n in such condition, I need to apply this, where h of 0 is already a real number. So I can rewrite this equation as h of 0, I take it outside, right, plus, and this must be also a real. The entire uh, h of k must be complex conjugate, and since it has to satisfy the condition of real, So which means that I can rewrite this equation as k runs from 1 because k equal to 0 I already took it outside. So 1 to p I will tell you. So why p I will tell you in the later case. So since this must be only I'm considering a real part here, right? I don't want any complex part. So what we do is I'm considering a real part of h of k into e to the power of j 2 pi k by m, right? So this is only a real part. So when we consider only real part, there are two conditions here. What is that? this m this m may be odd and this m may be even. The point is, if m becomes even, then if m is even, so if it all a real and symmetry, from the property of dft I know that h of m by 2 position must be also real, right? And that's what the condition that what we have chosen in my symmetric property of dft, if you remember the properly. So again, this p is depending upon whether p is even or p is odd, right? So if p is even, if m is even, p equal to m minus 1 by 2. Sorry, if m is odd, and p equal to m by 2 minus 1 if m is even. So this summation value will going to change. If I take a m point DFT, say for if it is 5 point DFT, then it is odd samples that I am considering, odd number of samples, then this equation will move from 1 to m minus 1 divided by 2, the last sample. If it is even samples, m is even, then this will be m by 2 minus 1 number of samples that I am considering. Very straightforward equation. Now, once we obtain the h of n values, then later point of time to obtain h of z, it is very easy. I apply a z transfer definition, that is h of n into z to the power of minus n, where n runs from 0 to m minus 1. Again, so this itself defines me, again, these many number of samples, whatever the m point dft that we have chosen, that the same thing m will be here, and obviously I am going to get a finite number of impulse responses or finite samples. So FIR filter is going to be designed in such a way. Similar technique we adapt here to solve this particular example by frequency sampling technique, where h of k I need to find out. So that is nothing but hd of e to the power of j omega. We are sampling this omega with respect to omega k 2 pi by m into k, where m is equal to 7 in this case. So that is nothing but hd of omega e power minus 3 minus 3 omega k is sampled from 2 pi, m is 7 into k, and k is equal to 0 1 2 up to 6, so totally 7 samples. So h of k is equal to e to the power of minus j 3. What is to be substituted here? Omega. In place of omega, I go for sampling technique of e to the power of 3 into omega. I will substitute this value, that is 2.7 by k. Sit down. So where k equal to 0 to 6. Now we know that to obtain the h of n. We have h of k here. Okay, I write the definition from this h of k. Now I try to write this in a much simpler way. H of k is equal to e to the power of minus j 3 2s are 6 pi 7 into k. Now we have this definition. So put IDFT for this. Now this is nothing but a DFT consider. Now put IDFT, obtain h of. That's it. To obtain IDFT, I will be using this formula. Okay. Because h of 0 should be real and I consider this to be a function. So uh, we know that what is the formula for DFT to obtain if h of n is real and even, so real and odd. So h of n is equal to 1 by m h of 0 plus 2 times summation k equal to m is odd, therefore the last value will be m minus 1 by 2. So real values of h of k into e to the power of j 2 pi k by m. Now we know that m is equal to 7. So substitute that value, and also we know that h of k is equal to e to the power of j 6 pi by 7 into k. So I'll substitute these two values in the above equation. 1 by 7 h of 0. H of 0 is nothing but when k equal to 0. I'll calculate this. When k equal to 0, h of 0 equal to e to the power of j into 0. That entire thing will be 0. Therefore, this will be 1. So by default, this is 1 plus 2 times summation k equal to m is 7. 7 minus 1 is 6. 6 divided by 2 is 3. So I am going to get only 3 samples. E to the power of j 6 pi by, okay, I'm sorry, okay, correct. My e minus 6 pi by 7 into k into, this is h of k I am substituting here, into this value definition of DFT as it is e to the power of j 2 pi k n by m, that is 7 here. Is it not? So bases are same. Add the powers. 1 by 7, 1 plus 2 into summation k runs from 1 to 3. So this will be e to the power of, I take out common factor, 2 pi by 7 I can take it outside, j also I can take it outside. So j I will take outside and 2 pi by 7 I will take it outside. K is common, I will take k is also common. Now we left with n minus 3 here, that's it. N is common, n we left out in this part, and here 3 is left out, so I'll write it as 3 after simplification, right? Now what is this? How I can write this as e to the power of j theta, right? Since I am considering h of k to be real only, okay, now I should eliminate the imaginary term, that is what the mean. So I can write this as cos theta plus j sin theta. Since I am considering my h of k to be only the real numbers, so I eliminate this. So in turn, I can write this equation as 1 by 7, 1 plus 2, summation k runs from 1 to 3, e to the power of j theta, and can be written as cos theta plus j sin theta. Since we are assuming that h of k to be real, then obviously we left with cos term that is cos of 2 pi k by 7 into n minus 3. Now I request each one of you to put this in a calculator. Okay, you are supposed to obtain the value of h of n, the value of h of n for n equal to 0, n equal to 1, and put k equal to 1. H of 0 is calculated. So 1 by 7 plus 2 into, again, cos of 2 pi k is 1 for the first iteration into 0 minus 3 plus 2 into cos of 2 pi again into 2 k equal to 2 by 7 into minus 3 plus 2 into cos of 2 pi into 3 divided by 7 into minus 3. So you need to perform this to find out h of 0, first value. To find out h of 0, the first value. Try to solve this, and similarly you need to calculate 3 values, because later on it is a symmetric values that what we have observed. Okay, try to find it out. So we are going to get h of 0 equal to, and which is equal to h of 6, because as I told you, this follows the symmetric symmetric property. So h of 0, h of 0, h of 1, h of 2, h of 3, h of 4, 5, 6. So h of 0 and h of 6 will be symmetric in nature. This is minus 0.1146, and this is also minus 0.4116. Sorry, minus 0.1146. H of 1 and H of 5 will be symmetric. So that is 0.079 and 0.079. And H of 2 and H of 4 are symmetric. These two will be symmetric in it. Like that, H of 3, H of 0, 1, 2, 3. I think this will be, I'm sorry, 3 and 6, okay, will be symmetric. Not 3, sorry, this is 6, 5, 6 and this one. H of 3, this is, sorry, this is H of 3, H of 3, H of 0 and 6, 1 and 5, 2 and 4, H of 3. So this is going to be your the final impulse responses. If you put it in calculator, similarly you need to calculate for 0, 1, 2, 3, that is sufficient. 4 values you are supposed to find, and in turn h of 0 you map it for h of 6, you map it for h of 5, h of 1, and map h of 2 and 4. Finally I need to obtain h of z. That is my final agenda. So this gives me FIR filter, right? How do you write the h of z for this? Very simple. H of n into z raised to minus n for summation what? N equal to 0 to m minus 1. What is m? 7. 7 minus 1, 6. That is h of 0 into z raised to minus 1. So therefore the first sequence will be 0.1146 into z raised to 0, it is as it is, plus 0.0793 into z raised to minus 1 plus 0.321 z raised to minus 2 plus 0.424286 z raised to minus 3 plus again this is h of 0, 1, 2, 3, 4. H of 4 is nothing but 0.321 z raised to minus 4 plus 0.0793 z raised to minus 5 plus 0 again minus 0.114 z raised to minus 6. So if you observe carefully, the h of z consisting of only zeros, there are no poles in this equation. Is this clear to all of you? Uh, uh, any equation given e to the power of, it may be e to the power of minus j 3 omega, or it may be e to the power of minus j 2 omega, whatever the value they may give, you need to go for sampling this as we did in case of DFT. So once we obtain this equation, again you need to adapt. So you need to adapt the IDFT technique here. So it is nothing but IDFT definition that what we wrote. But here we considering the real values, because if you please move to symmetric definition and symmetric and real condition, and there we have derived this formula. Uh, the entire formula is derived in our DFT chapter, and from there itself I have taken this. That's it. Okay. That's what here also I told you about P considering that m equal to odd and m equal to even. If you remember properly, there also we have performed the same thing in DFT chapter. Okay, if not, I request you to go through that particular video, and you can come back to this session so that you will understand much clearly. Okay, ultimately you need to use this formula. You need to use this as a formula to obtain the frequency samples. Okay, to obtain the h of n values. Okay, let me stop here and I'll come back to chat window.